Domain drop-down allows the auditor to evaluate different operational areas, such as HR, finance, inventory, manufacturing, or audit, using the same governance framework rather than different logic for each department. It ensures that KPI, TSI, OSI, graphs, and the analyzer verdict are interpreted consistently across domains, so the organization does not change decision standards when context changes. In audit terms, this enforces uniform policy application. The data varies by domain, but the permission rules remain constant, making approvals comparable, repeatable, and legally defensible. What this cockpit is: auditor purpose. This modular evidence cockpit 2026 prototype is an auditor-first decision evidence screen, not a normal analytics dashboard. It is built to enforce the IGA 2026 rule that pure AI stays in inform, while permission to act is controlled in govern. Every panel is designed to answer an audit question: is the system stable, transferable, and safe enough for real decisions, and can we prove it later? Module selector plus KPI/TSI/OSI cards. What the auditor checks first. The module selector, HR/finance/inventory/manufacturing/audit, lets an auditor evaluate domain-wise evidence using the same governance spine. The KPI/TSI/OSI average cards are the cockpit's quick risk lens. KPI shows performance capability, TSI shows support dependency, how much help/context is needed, and OSI shows outcome reliability. Auditors look for alignment. KPI should not remain high while OSI falls, and TSI should not degrade sharply because that indicates confident predictions with weak real-world outcomes. Trend chart: behavior stability across training/test/unseen. The line chart is the behavior stability test. It shows how KPI/TSI/OSI move record by record across training, test, and unseen. An auditor is not looking for a perfect upward line, they are looking for controlled variance and transferability. If unseen lines swing more than training, or OSI diverges from KPI in unseen, the audit interpretation is, the model learned, but operational behavior is not stable. That moves the verdict from pass to watch/fail until stability is proven. Dataset averages bar chart, summary control point. The bar chart compresses the story into one view: how training vs test vs unseen compare on KPI/TSI/OSI. Auditors use this as a control checkpoint. If unseen averages drop, it signals deployment risk even if training looks excellent. In governance terms, training is education, test is controlled discipline, and unseen is real-world trust. For approval, auditors expect unseen OSI to stay close to training OSI, otherwise the system is restricted to inform-only guidance and must remain under a governance gate. Analyzer 1.0 Verdict Gate plus Evidence Export, Permission plus Traceability. The Analyzer 1.0 Verdict Gate is the cockpit's core. It converts analytics into permission control with three outcomes: pass, controlled permission, watch, supervised use, fail, blocked. This is where governance replaces automation. Intelligence cannot become action unless the gate permits it. Finally, evidence export, audit JSON, ensures traceability. The cockpit records module, verdict, timestamps, dataset counts, file names, KPI/TSI/OSI averages, and text evidence without exporting raw data. The result is a regulator-ready audit trail where every decision is explainable, reviewable, and defensible. In NeuroGov Plus/IGA 2026 auditing, the three graphs are treated like three stages of evidence before authority is granted to AI. They answer three different risk questions, not one performance question. 1. Training graph learning capability. Audit question: can the AI understand the data it was taught? What auditor checks? KPI high and smooth. TSI supportive. OSI close to KPI. Meaning, the model has learned patterns correctly. But important. This graph proves only memory, not intelligence in the real world. Audit decision. Heavy check mark capability exists. Cross mark no operational approval. Training graph certifies education, not trust. 2. Test graph controlled reliability. Audit question, does the AI behave properly outside memorized data? What auditor checks? Small fluctuations acceptable. KPI and OSI should remain aligned. TSI should not collapse. Meaning, the model can generalize under supervision. Audit decision. Warning conditional stability. Warning needs governance monitoring. Test graph certifies discipline, not safety. 3. Unseen graph real-world safety. Most critical graph for approval. Audit question. If deployed tomorrow, will decisions remain safe? What auditor checks? KPI OSI stability. No sudden drops. No confident but wrong behavior. TSI does not fall during critical records. If mismatch occurs. High KPI plus low OSI equals dangerous AI. Audit decision. Heavy check mark stable rightward arrow deployable under NeuroGov+. Cross mark unstable rightward arrow blocked by Analyzer 1.0. Unseen graph certifies trustworthiness. Final auditor logic. Graph what it proves deployment value. Training AI learned none. Test AI disciplined limited. Unseen AI safe required for approval. See the governance principle. Accuracy is education. Consistency is behavior. Stability is permission. One-line auditor conclusion. An AI passes when it predicts correctly. But it is approved only when it behaves safely in the unseen world. Dr. Pradeep K. Suri, inventor and architect of the 3D, 10D AI-DNN engine, Cognitive Cube, Analyzer 1.0 and NeuroGov+. His work advances governance-first AI where intelligence informs and authority decides, ensuring safe, auditable and sustainable enterprise decisions.